Hi, my name is Paul. I've spent the last 2 years building process, system, service, and capability models as an enterprise architect for the DoD. I know how to analyze business processes and enterprise systems to find areas of inefficiency and can recommend ways to improve them. I'm also an AWS certified solutions architect, and through Savvy Coders, I also have some experience with data analytics and Python. Some of the things I am passionate about include solving complex business problems, building a positive, productive company culture, and lifelong learning. I love learning new things and acquiring new, valuable, and applicable skills. I am also extremely passionate about football, in particular, the Kansas City Chiefs. I was raised a part of Chiefs Kingdom by my father, and I don't think I've missed watching a game either on TV or in person since I was about 12. With the Chiefs' success in recent years, my life has only gotten more stressful due to them playing in much bigger games. I remember the days of the past when all I was worried about was who we might draft this year so that we might get that much better next year. Which brings me to my Capstone project. Each year, 32 NFL teams, every sports media outlet, and millions of fans try to determine which college football players will be the most successful in the NFL and have heated debates over who should be drafted over who. One of the main ways a player can showcase his potential is at the NFL Combine, where they measure each player's athletic traits. So in this capstone project, I wanted to find out if there are any measurable traits that we can know about a player before the draft that would help us determine how much success they might have in the NFL. I will be looking at whether a wide receiver's speed, height, and or wingspan, in addition to vertical jump and broad jump, translate into receiving yards in the NFL. So at the NFL Combine, the players can participate in all kinds of different drills and physical performance metrics that have to do with just various things about whether they might make a successful player in the NFL. They don't have to compete in all of them, but the reason I chose these five, the 40-yard dash, the arm length, height, broad jump, and vertical jump, is what are the traits I would call separation creating metrics. In other words, can a wide receiver create more separation between him and whoever is covering him, which I believe would be the most important traits into gaining the most yards in the NFL. So in terms of wide receiver NFL performance, we're going to be specifically looking at how many yards per game did this wide receiver average throughout their NFL career. And that's mostly just due to the fact that touchdowns and kind of all the other metrics like number of receptions and things like that are a little more arbitrary. You know, if you're getting 5 1-yard catches a game, not that big of a deal. And, you know, maybe one player has thousands of yards more than another, but caught a couple less touchdowns because not all of them are in the red zone. So I thought that yards per game was probably the most important metric in order to kind of capture a wide receiver's talent overall in the NFL. My sources are here on the screen. The one you see up top is NFL Combine results. So this is where I got my Combine data for players all the way back to 1996. So we went back 26, 27 years. And the one you see on bottom is the NFL receiving stats year by year. And that one was populated by year, so I had to pull them each individually back 26 years. So here is a couple screen grabs of my work in Python for the project. The top one is a little bit of my web scraping. So I was able to use the Combine Data website was not able to pull data directly from the website and download it into any kind of file. So I had to web scrape that one. And so I was able to use the requests, the Beautiful Soup and Pandas libraries to scrape the data from the web, parse it out, and put it into a dictionary, which I was then able to put into a data frame and save that as a CSV file. The other, for the other stats, the NFL wide receiver stats, I was, like I said before, I pulled 26, 27 years or so individually, all the way back since 1996. And so I had to concatenate all of those different data sets into a single data frame in Python. And then, as you'll see on my next slide, I have a slide showing our Excel sheets. But after I saved those the first time, I realized that a lot of those players, those NFL players, had a lot of them would have like stars or a plus after their name that would indicate different things within Pro Football References database. But it was not going to be helpful in order for combining them with the combine results. And so those stars and pluses had to be removed so that the names would be the same as my other data sources with the combine results for the players. So you can also see a little bit there of where I had to go through and remove all of those ending kind of special characters on the end of the names and replace them with nothing. And then, exported that to a CSV. So here were my results. Like I said, I put a screen grab in of how the database originally looks like when I concatenated all of them up top. You see the players with the special characters after their names a lot of the time. And then the one on bottom is my combine data in a CSV. You'll notice there's a lot of blank spaces, and that is due to the fact that, like I said, players don't have to participate in every single measurement at the combine. They don't have to participate in any of them, actually. But the 5 that I chose do have a pretty high participation rate. So we didn't have too many nulls in our data, but we did have a fair amount. Next is my SQL. So I pulled my databases into SQL. And so for this one, I selected just those wide receivers who had played in at least 17 games. And the reason I did that is to exclude all of those NFL players who, maybe were drafted in later rounds as rookies and kind of didn't really play any games in the NFL, or maybe played a few games here and there, but were mostly on the practice squad, things like that. So I wanted to limit it to just players who had actually had reasonable playing time in order to kind of assess their talent on the NFL field. So I selected only the columns that I wanted, and only those players which had played at least 17 games. And then I also removed all nulls here. So I selected only the players with data in those performance metrics, the 40-yard dash, arm length height, broad jump, and vertical jump. And then I pulled that into its own CSV file, and then pulled it into Tableau for us to start kind of modeling that data out. So how I modeled it in Tableau is to just do scatter plots with the yards per game against each metric. So you're going to see 5 different graphs here that kind of look pretty similar, but they're for each of the 5 different metrics. First up here, we have all of those wide receivers plotted with their yards per game on the y-axis, their 40-yard dash on the x-axis. So towards the left side on this one is actually the faster players, and towards the right side is the slower players. So I did add trend lines to all the data so you could kind of see, because, I mean, immediately visually what you see is that it's kind of a big blob. There's not a whole lot of kind of clear direction in it. But you can see that when you add the trend line that it at least is trending in the right direction, even if it's not significant. It's only got an R-squared value of 0.01. So again, right direction, but not a significant or clear trend there. For the second graph, we have yards per game modeled against arm length. And it's honestly surprised me, but this was actually the strongest correlation in all of my data for each of the 5 different traits, with an R-squared value of 0.016. So you can, this is kind of one of the only ones in which you could kind of look at it and see, okay, there is like a little bit of a trend there. Again, not a strong one. So you definitely couldn't draw any kind of conclusions of like, greater arm length is going to correlate to more yards per game. But there at least is kind of a trend there. Height, this one I think it's the weakest of the 5 with an R-squared value of 0.007. Again, trending in the right direction, but a very weak R-squared value. Next, we have broad jump. And so the pattern you will see, again in this one, and you'll see in the last one too, is that we are always trending in the right direction, like the direction we would expect to see. Faster, taller, longer arms, higher numbers for the broad jump and vertical jump are all trending in the direction we would expect them to trend in. However, they're all pretty weak. This one is 0.012. And lastly, we have the vertical jump as the second strongest R-squared value with 0.013. So that brings me to my takeaways. Just to start off here, I would say that the biggest challenges that I ran into were, first of all, just the format of player names is kind of a challenge when you're trying to get databases to match. Simply because, well, there was the challenge of the special characters at the end of the name, but then the second challenge is that one database might have like AJ Dillon, whereas another database might have AJ spelled out into his whole name, which I actually don't know, but so they would, or like for Jamar Chase, one might put an apostrophe in the middle of Jamar and another might not. So getting those names to match was kind of a manual process of having to go through and find which ones did or didn't and get them to look the same in SQL so that I could join those two together. And then there's also the fact that, again, players didn't have to participate in all the different measurements at the combine. So you don't have data for everyone, and you can't compare, nulls against normal data, obviously. And I didn't think that this was a scenario in which I could just kind of put in the middle value for players, because I thought that would have skewed the data incorrectly. And lastly, just the web scraping is always a tough one to kind of do correctly on your first try, but was able to do that after a few hours of research. So in conclusion, my takeaways from the data are that just while every combine measure does have a slight correlation, none are strong enough to say that they would have an impact on wide receiver performance. If the combine data was all that we knew about a player, you could make an argument that you would have higher odds of drafting a better wide receiver by going for the one that was faster or taller or could jump higher. So in the absence of any other kind of scouting data or anything like that, or just college stats or things like that, you could make the argument that you should go with the player with the better combine stats. But based on the weakness of the correlation in the data, I would suggest that you should go with the expertise of scouts, who are experts at evaluating the intangibles. Obviously, there's going to be a lot of hits and misses there. Scouts are wrong all the time. But in general, you do see a lot of players becoming great players when they're drafted higher than being drafted in the lower rounds. So scouts are at least doing a somewhat decent job. And there's no evidence to suggest, at least from my findings, that the NFL Combine measurables could be any more successful of a method than scouting or college stats or anything else you might use. So I'd like to thank Savvy Coders for everything that we've learned throughout this semester, throughout this boot camp, and just all the teachers and TAs who helped me along the way. Thank you. And that brings me to the end of my presentation.